Hello everyone, welcome back to the another session in design and analysis of algorithms. So today we'll be going to talk about traveling salesman problem using branch and bound. You'll find this topic in 4th unit as topic number 7, the last topic of 4th unit. And today we'll be going to learn about what is traveling salesman problem, and this problem we were solved using other techniques, right? So what are the differences in between backtracking and branch and bound? And also we'll cover one example problem, finding the solution for one example problem. So we'll take textbook problem. So these are the things what I'm going to talk in this video. Now let's get started. So what is traveling salesman problem? Traveling salesman problem is what? You have to find a path by visiting all the vertices of a graph, and the tour has to get finished where you started. Now let's take some example that I'm taking some graph. Now this is the graph. Now what traveling salesman will do is, he wanted to visit all the vertices at least once, right? Now, only once, not at least once, only once. So when he started the journey or tour from starting vertex, which is 1, he can have his tour from 1 to 2, 2 to 3, 3 to 4, and for sure he has to come back to the starting city, which is 1. So this path can be of anything, right? So whichever path is available, that path he'll choose. Now what is the objective of this traveling salesman problem using branch and bound technique is, we'll consider a graph and find the shortest tour and calculate the cost of the tour. So this is what objective of this problem. Now we have to find out the shortest route that is going through all the vertices once and returning back to the starting vertex. So to explore this problem, we'll take state space tree. Now what is state space tree? Let us see that he started his journey with vertex 1. Now he can go to second vertex, and he can also visit third, or else he can visit directly fourth. So this is what actually I told you, branch and bound technique. As far as branch and bound is considered, visiting of the vertices or generating the exploring the node, generating the other node will be always level by level, that is of BFS. So he started his journey with vertex number 1, and he will come to vertex number 2 if he found any path. So as far as this example is considered, he is having a path from 1 to 2. So he is also having a path from 1 to 3 and 1 to 4. These are the possibilities that he can visit 1 to 2, 1 to 3 and 1 to 4. Right? Now, if it is a backtracking, then it is what? He will come to 1 to 2, and from 2 he has to go to the other things, right? 2 to 3, and we'll take the other possibility. As I told you that we'll be going to implement this problem with branch and bound, and it follows a BFS order, level order. So he will go like this, 1. So he's having these possibilities, 2, 3, 4. Now, so we already come across with branch and bound techniques. There are 3 strategies to implement state space tree as far as branch and bound is considered, which are FIFO method, LIFO method and LC method. So I'm going to use LC method, least cost method I'm going to use to solve this problem. As far as this problem is considered, after I have a travel from 1 to 2, from 1 to 3, from 1 to 4, I have to see the cost of 1 to 2, 1 to 3, 1 to 4. Whichever cost I found it is minimum, that node is going to be get explored. Right? Now after I found here, let us suppose that I have found a minimum path from 1 to 3. So 1 to 2 node, 1 to 4 node, I'll not explore. I'll stop exploring these 2 nodes, and I'll start exploring this node. So again I'll explore here. I have already completed visiting of 1 to 3, and what else that 1 to 3 is visited. So I told you in the beginning of this video that traveling salesperson have to visit once, only once. He has to visit all the vertices only once. So 1 to 3 he has finished his visiting. So he can go to 2 to 3, or else he can go to 2 to 4. So now you have to calculate the cost from 3 to 2 or else from 3 to 4, right? So if it is after you found cost in between 3 to 2, you'll get one figure. Let us suppose that is of x, and 3 to 4 he has a cost of x1. So if x is less than from x1, then start exploring the x, because as far as least cost searching method is considered, we have to explore the nodes whichever is minimum. Now if it is found that x is less than from x1, start exploring this node. Fine. So this is what actually objective of traveling salesman problem with branch and bound approach. Now we'll take some example. Now let's see this example. So this is what the graph what I'm considering. 1, 2, 3, 4. So I'm just taking the example graph. Now, so here it is. Now I have given a graph, right? 1 to 2, 2 to 3 and 3 to 4. So according to this graph, I'm generating the state space tree. So as far as the example is considered, he can visit 1 to 2, 1 to 3, 1 to 4. So after he found which is least cost, then that node will get explored. Let us suppose that I wanted to explore using a FIFO method. Then first in first out, we'll start exploring 2 node onwards. If it is last in first out, we'll start exploring the 4th node onwards. So I told you that I'm going to use least cost. So I'll find the cost of each node. Then I'll choose whichever is lesser than all, that node will get explored. So this is what branch and bound technique. Now let's understand the differences in between backtracking and branch and bound in the same example. So backtracking and branch and bound are similar. Both uses state space tree, but the approach is for solving a problem is quite different. Now let's see, the first difference is what? The order. We'll write fresh slide so that you people can also have a note, because as it is an important question for examination purpose, end semester examination purpose. So you can have a question differences in between backtrack and branch and bound with an example. You can take this example, so that the graph what I have drawn just before that, the example you can take and you can start explaining like this. The first difference is what? The level, the order. So backtracking uses DFS. What is DFS? Depth first search. In other sense, you can tell it is an pre-order. That means it visits 1 to 2, 2 to 3, 3 to 4. When? If it is a backtrack. Let's see. So after it came to 1 to 2, 2 to 3, 3 to 4, if it founds that means if the traveling salesperson wanted to take the other path, it will get backtrack. From 4 to 3 backtrack, 3 to 2 backtrack, and he can change his decision from 1 to 2 to 2 to 4, or else he can go complete backtrack to 1 vertex. Now he can change his decision and he can come to 1 to 3. So again 1 to 3, 3 to 2, 2 to 4. It is one of the solution, right? Now again he can change his decision 1 to 4 and 4 to 2, 2 to 3. And he can change his decision 1 to 2, 2 to 4, 4 to 3. He can go in order of depth first search, right? So this is the first difference. And the second difference is, as far as backtracking is considered, every node is a solution. This node is a solution. All the leaf nodes in backtrack is a solution. So that's what backtracking will take more time. It is a time consuming method. We don't want all possible tours. We want a tour which is minimum. So we will find cost of all possible paths and we'll consider the minimum one. And let's see about branch and bound. What is branch and bound? Branch and bound is a technique. It is also for optimization problem, but the optimization problem is minimization. Now, So it uses BFS, that is of level order. So what is the level order? Now he can start his traveling or tour from 1 to 2 and 1 to 3. He'll not go to this path, the path which is visited in backtracking, that it is not the path of branch and bound. He'll go 1 to 2 and 1 to 3 and 1 to 4. Then he come down to the next level, which is 2 to 3, because he already completed his tour from visiting of 1 to 2. So now he can visit 2 to 3, or else he can go to 2 to 4. So level by level will complete in this branch and bound. For every node we'll find the cost and we'll consider the minimum. So we'll find the cost of all and we will be choosing the whichever is having minimum, and all other nodes will kill when the cost of a node is greater than the upper bound. Let's see, upper bound cost is something like 32 and you got all the cost as something like 45, 55 and now the figures. Then the 32 is minimum and 45, what you get the solution is 45, and that was the maximum than 32. So as it is a greater cost of this 32, you have to kill it. Okay, now let's suppose this is of 25, all are greater than 32, 45, 52, 46, something like 38, something like 39. So among all this, which is minimum cost? This 25 is the cost. So what is the path? 1 to 2, 3, 3 to 2, 4 and 4 to 2, 2. So this, and again back 2 to 2, 1. That is 1, 2, 3, 4, 2, 2, 1. This is the path he has visited for the cost of 25. So what about all these solutions will kill it? Will kill if the node has the cost in this level 38, will kill here. If the cost is more here, will kill here itself. So using the bounding function, what is bounding function? If the cost of the present node is greater than the upper bound of state space tree, will kill the node whichever is producing more cost. So that is what bounding function. So these are the main differences in between backtrack and branch and bound. Now let's see the example. So